Hello everybody, my apologies on the retake of this video. If you saw the original one and couldn't hear anything, that's because of an issue on my computer and I have since fixed that. So what I'm going to do is I'm just going to record this video again and hopefully it will work out better. So let's start with identifying functions from tables, graphs, and ordered pairs. Okay, the first thing we need to know is the definition for the word relation. So a relation is just simply a set of ordered pairs, or you can interpret that as just points on a graph, any set of x and y coordinates. There doesn't have to be any rhyme or reason to it. A function, however, a function is a special relation that puts each domain value. So when we think domain, I want you to think x coordinates. Each domain value must pair to exactly one range value, which I want you to be thinking y coordinates. And if you're looking at a graph is a function if it passes what we call the vertical line test. Okay, and so many of you already know what that means, but we will talk about that as we look at these examples. In the first example, since they give us a list of basically we can equate each row as like ordered pairs, we can see that there is a single domain value that has different range values. Well, that violates our definition of a function that says each domain must go to exactly one range value. So this is not a function. I always look at my x values, and if I see x values that are repeating but with different y values, that makes it not a function. The next one, I would use my vertical line test, and the vertical line test passes if only one vertical line goes through a point. If a vertical line goes through 2 points, it is not a function, but in this case, it didn't, so it's a function. On the next one, again, look at your x values. All of my x values are different, so that means that there's no way that we'll violate each domain goes to exactly one range, so this is a function. Okay. On the next one, well, I can draw a vertical line right here, and we're passing through 2 dots, so this is not a function. On the next one, if you were to draw vertical lines through this graph, this would be a function. There would be no vertical line that goes through 2 points. On the last one, I can see this example right here. We hit 2 dots, so this is not a function. Okay. All right, so let's get into some of the more algebra with functions. So function notation, we use this notation, looks like f parentheses x. We read this as f of x. Now keep in mind it doesn't have to just say f. This is just the name of the function. So it could be called any letter. And this is the input variable. Usually when you have the equation, that's going to be the variable in the equation. And so that's our domain. F of x, which that quantity right there is the range because it's the output value. That's just the same as like if you saw y equals in an equation. So the input is the x and the output is the f of x, or generally whatever f of x is named as and what the variable is. All right, so let's look at an example. I have y equals negative 5x squared plus 3x minus 1. To rewrite that in function notation, we just rewrite y as f of x. And so that's just our function notation. The variable that shows up in the equation is the same as the input variable here. So to find the values of f of 0, f of negative 2, and f of 3, we just plug in those x values into our function and simplify. So in this case, if we look at the order of operations, we're going to see that these terms are zeros. So f of 0 is -1, okay? With f of 0 equaling -1, that implies the ordered pair 0, -1 is on the graph. If I do the same thing with the next one, we just replace the x's with -2's. -2, when I square that, notice the negatives in the parentheses, so we get -27 here. That's the value of f of -2, which implies that -2 comma -27 is on the graph. On the next one, same process. I'm going to do this one a little bit faster because you should hopefully know how to use your order of operations. If I'm going too fast, please make sure that you pause your video and catch up. Although right now I'm going to use a calculator because I don't feel like doing mental math right now. Alright, -37. So this implies that 3 comma -37 is a point on the graph. Okay. Alright, for this next example, this one, I'm going to have you try this on your own. So I'm going to pause the video, let you work out part A and part B, and then we'll talk about C and D. If you did part A and part B correctly, what you see on the screen now is what you should have gotten as your answers. So just a little practice there. But I want to draw attention to what C and D are asking. Part C says, what is the value of x if f of x equals -10? So we're not replacing x with -10 as we had been doing in the last examples, because this time the output is -10. So I want to know what input gives me an output of -10. Well, some of you might be saying, oh, well, we did that here. When we plugged in 2, we solved it and got -10, so x has to be 2. And that is correct, but I'm going to show you how you figure this out algebraically. Since f of x is -10, -10 is going in as the f of x, and so you'd have this equation. So we're going to solve this equation. Oops, that should be -10. I was like, wait a minute. And when we divide by -3, we get +2 is x. And therefore, we have just shown what we kind of thought all along. So if I look at the next one, what value of x allows f of x to equal 5? That means we're replacing f of x with 5. So it'll go 5 equals -3x minus 4. So solving this out, we would get next value of -3. And if you were to go the other way, if you plugged in -3 for x, -3 times -3 is +9, and then 9 minus 4 is 5, which is what we wanted to end up with. Alright, last one here. This time, if we're looking at a graph, if I want to find f of 0, remember this is our x-coordinate, so I look for x is 0, and I see that happens up here at 90. So we know 0, 90 is on the graph. F of 5 means I go to f of, so I go over to x equals 5, and it looks like the graph is right there. That ordered pair is 5, 0, so f of 5 equals 0. And for f of -2, for that one, it looks about halfway between 0 and 30, so we'll say it's 15. And that one we had to estimate it because we don't know exactly. All right, the next one's a little more interesting because it asks us, well, what is f of x, or sorry, when is f of x equal to 0? So you're asking yourself, what are the x coordinates that give you a y coordinate of 0? Well, we already saw one right here where we had 5, 0. So x equals 5 is one of them. But there's another time when this happens, and that happens over here at -3, 0. So the y-coordinate's 0. So it also happens at -3. Okay? All right, now for the last one, to do this one, I'm going to erase the orange that I have there. This one says, when is f of x equal to 60? So here is my line with 60. What I do is I like to kind of just draw that line all the way across. And we're trying to find the x coordinates that intersect that 60 line that I drew. And that happened 3 times. So our goal is to tell the x values. So it looks like the first x value is somewhere between -4 and -5. I'm going to guess about -4.6. This next one happened somewhere between -1 and 0, so I'll call that -0.5. And the other one happened between 4 and 5, I'll call that 4.5. And again, we're just estimating those because we don't know exactly, but we have a rough idea. All right, so hopefully this will allow you to be able to work on the assignment that is on Delta Math and come to class with questions.